Okay. Welcome to Wednesday of week 9. We've spent some time going over fractions and percentages in the justice section, our third and last section. Measurement we haven't started yet, and I'm sure we'll restart it today. I'm not sure how far we'll get. First, let's do homework questions. Who has homework about the fractions or percentages part? Number 7 and what? The turn-in problems? Okay, number 7 of which section? Fractions. Okay. Okay, so first let's read the problem. A certain dog medicine contains 3/7 of a gram of active ingredient for every 120 gram dose. For a small dog, how much active ingredient is in a 7-gram dose? So, what kind of problem is it going to be? Which of my math toolbox tools do I use? Proportion, says someone. Okay, and how does she know it's proportion? Because they give us 3 things and ask us for a 4th thing. And the setup is that we have one situation happening on one side and another situation happening on the other side. So those structure things. 2 situations, we have 3 of the 4 numbers. That means a proportion is happening. Okay, so I start reading 3/7 of a gram. And that's active. So if I just put gram, let me do this wrong first. Then I'm not sure where things will go on the other side because it's all just grams. So I also need to write a little more words. Active dose. And then I know, without having to read more, that the other side has to match. This has to be active grams on the top and dose grams on the bottom. Because in proportions, you always have to have your words match. If the same thing on the top, then the same thing on the bottom. Everyone okay with my setup so far? Then I keep reading. There's a small dog, so it's only a 7-gram dose. How much active ingredient will I have? So far I haven't made any choices. I've read the problem, saw that it has a 2 situation, give you 3 numbers, find the 4th thing, so I made it a proportion. I put one situation on one side, and however I labeled it on that side, I labeled it on the other, and then I kept reading and put the last stuff in where it had to go. Okay, now I cross multiply. Oops. I'm going to make that 7/1. So what's 3/7 times 7/1?
Cross out the 7.
Yeah, cross out the 7s. We get 3. The thing that's stuck onto y is a times 120. So the opposite is a divided by 120. So 0.025.
And as a shortcut, we could just do.
Yes, if you're done at Math 20 and not going into Math 60, do the little shortcut. If you want. Whoops, word problem, I need to label my answer. Grams, and which one am I looking for? The grams of active. Questions about that one? Which part did you get to before you got stuck?
The first,
Or knowing it was a proportion or just putting, okay.
splitting it up in 7.
Ah, there. Okay, that's kind of the middle. Other questions about what we've already done? Anything with the fractions or the percentages? Okay, well, let's move on a little bit. So measurement, temperature. All the stuff we've done so far with changing one measurement unit to another, with multiplying and dividing, or if you were complicated with unit analysis, that works because 0 is always 0. If I have 0 inches, that's the same as 0 feet. That's the same as 0 miles. You can't just change things with multiplying when the zeros don't match. And you would think, well, zeros would always match, right? If I have none of something, then I have none of it. But that's not true in temperature. Because of an accident of history, then Celsius and Fahrenheit don't match at 0. So we need to memorize some formulas. There's a cute story I could tell you if you really want about why the Celsius formula is the way it is. Yes? Okay, so why is the Celsius formula the way it is? So, I don't know, does this desk have one? No, okay, well, if it was years ago, people would give me a protractor in my math desk here. Everyone knows what a protractor is for measuring angles. It starts at 0 degrees and it goes to 180 degrees. So, I'm saying Celsius, Fahrenheit. So when Gabriel Fahrenheit was doing his invention of measurement units, then this was his model. He thought 0 should be really cold and 180 should be about as hot as I care about. So what was he going to pick? The coldest he could get, mixing salt and other stuff in water and then freezing it, would be his 0. So normal water freezing was a little bit above 0 because he wasn't interested in what was happening kind of outside on his lawn. He wanted the coldest he could make in the lab. If you mix stuff in water, then the temperature at which it freezes goes down. That's why we salt the roads in this ice storm, because we want that liquid to freeze at, say, -20 when it's -10 out, and that way it will still be liquid when we're driving, right? The temperature at which it freezes goes down when you mix stuff in water. So this was his laboratory, mix stuff up. And since then, we've gotten better. We can get temperatures in the laboratory well below what he was able to, but that was his goal. And then 180 would be when water boils. So far, so good. And then he did more measuring and found out that human body temperature was close to 100. Not quite, but close. And close enough, he thought, that's something people will care about. If I'm ever going to make money selling these things, I want human body temperature to be an easy number to remember. So the best he could work out was, let's just make that 100, as long as I'm defining everything. So by adjusting everything in his earlier calculations, that moved this to be 212 for when water boils. and made water freezing even different than it was before. So it went all the way up to 32 and things like that. But it's still true that if you look at a normal Fahrenheit thermometer, between the 32 and the 212 is 180 degrees, because he was working on this model to start with. And I've read different things historically. I'm not sure if he ever made thermometers that weren't straight, but were shaped like a protractor to be the 180-ness or not. So in any case, I think the historians agree he kind of died poor and this never took off, but still we get his name on thermometers. Anyway, thermometers, Fahrenheit, here we go. So Fahrenheit is the standard one, Celsius is the SI or metric one, and sometimes we'll need to go back and forth. If you need to go back and forth, you need a formula, again, because zeros don't match for them. And you get your pick. You need to memorize. I think we always give it to you. You might want to memorize one formula from each category. These are the formulas up top where you plug in Celsius and it spits out Fahrenheit. You visit Canada and they measure something in Celsius and you're trying to think, wait, what is that Fahrenheit that I'm used to? Or these are the formulas you plug in Fahrenheit and it spits out Celsius. This is someone from another country visits the US, reads what our temperature is on a nice sunny day and says, wait, what is that in Celsius that I'm used to? The traditional ones that probably you've seen in other math classes are the top ones. If you like fractions, then you can do this one. And then Robert Warren invented these because they're almost the same. It's just whether you have a 9/5 or a 5/9. Other than that, you don't have to worry about plus and minus switching around or anything like that. So if you haven't memorized or seen any of these before, the bottoms are probably the easiest to memorize. If you're used to others, go with the ones you're used to. Let's check on the final. Do I actually give you these formulas? I think I do. No, you have to memorize that. Okay, so you memorize one formula of each kind. So one from the top three and one from the bottom three. Then you can go in both directions. You need to memorize moving around it within the American system, the standard system, pints, cups, quarts, feet, yards, miles. You need to memorize one each of these. And then the King Henry, yeah, that one. Okay, so let's actually do this. Does anyone have a favorite formula to use here? Now, first of all, are we going from Celsius to Fahrenheit or from Fahrenheit to Celsius for number 90? From Celsius. So we need one of these three where Celsius is the thing I plug in. So why don't I grab the first one, because I think most people know that one. Most people have seen that one. Okay, memorize. Right. So Fahrenheit is 1.8 times where the Celsius is. I just plug in the 39 plus 32. If I'm doing this bit by bit, remember terms, right? The multiplying happens before the adding. My calculator, of course, doesn't care. It just does everything. 2.
Do you want me to use all this batter?
Yeah, what?
Do you want me to use all this batter?
Whatever you want. I don't know how hungry people are.
Make it easier. Raise your hand if you guys are going to want pancakes. Right?
Okay.
It's me in general like that.
Yeah, so difficulty, this is a kind of give me a point problem, right? You need to memorize this, but the calculator does all the hard work.
Can you go back to the formulas?
Yes. So there's the formulas.
Can you go back to that?
Yes, I can, but someone just asked for this, so we'll later times. Again, of the three, you only need one. This is sort of an old traditional one you've seen before. This is the fraction one for people that like that, which pretty much no one does. And this is the one that's easiest to memorize, both of them, if you haven't picked a favorite yet. Okay, now to the previous one. There we go. There's for Lexi.
Thank you.
You got it already?
Not yet.
Not yet, okay. I was going to say, that's really good. Okay. Okay, so we pick another one. I'm still going to use the one that's sort of boringly familiar. Because for the others, you have to remember which one has minus and which one has plus. The last one of each set, you don't have that. Anyway, there's an F. I plug in the 73 where the F is. Now, why does this formula need parentheses? Yeah.
Could you go back to the last slide really quickly?
Sure. So this one, I need the parentheses because otherwise the division is going to happen first, right? Order of operations would normally do the division first. So if I'm going to break that, I need the parentheses. So 73 minus 32 and then divided by 1.8. So about 22.8. So this should make you both groan and be happy. Groan because you have to memorize some things, and happy. I rounded it a tiny bit. Yeah. Temperatures are like dollars and cents. You don't really have to worry about how much to round. Make it a whole number, maybe a tenth of a degree, right? Unless you're using really fancy lab equipment. That's how accurate they are. So. Okay, questions on these? Okay, so there's not much to them. Did we talk about this one already? Have we done this area puzzle yet? I'm sure we have. Let's pretend we haven't. So some problems that we've done with area were just one shape. Here's a rectangle, here's a triangle, here's a trapezoid, here's a parallelogram, here's a circle. Find its perimeter, find its area. When we have things that are pasted together, then it gets a little more interesting. So yourself, before I spoil the answer, find the perimeter and area of that shape and compare it with whoever you're sitting next to and see if you agree. If If you and your neighbor agree, then somebody go and help him pass out the food so he doesn't have to walk as well as cook.
I'll help you.
No, I've been here. She didn't notice, she was looking at a calculator. I noticed she's wearing shorts. Yesterday was 60, so I don't like it.
Okay, so perimeter and area. Perimeter we'll do first. Which corner did people sort of start their ant walking at?
I'd say the top is 6 inches because the bottom you have 2.
So I'm gonna say we start here. 2 and 4 does make 6. And how much is B? A was 6 because it's 2 and 4. How much is B?
Everybody's skeptical.
Okay, that side that's talking too much. Shh. People can't hear. How much is B?
So it's, I have to more, there's more batter.
Would it be 2?
Would you put five?
Would it be 2?
Well, we have this much is 2.5. This much is 1.
It'd be 3.
Every
1.5, right? Because the whole thing was 2.5. So if we take away that amount, which was 1, what's left is the 1.5.
It's so weird.
It's so weird, the first one that I used to ham with. It wasn't.
Everyone okay with A and B before we go on?
Yeah, she did.
Okay, so now to find the perimeter, we just add this up. So we need to do 6, 8.5, 12.5, 13, 14, 15, 16, so 17 inches I'm getting. Everyone happy with that?
You just add it all up.
Yep. Notice that if I wanted, I could sort of pop out this corner and make it a rectangle that was just 6 and 2.5. And then I can add that up easier. 6 and 6 is 12, 2.5 and 2.5 is 5, 12 and 5 is 17. So it doesn't matter when you're going from here to here, which half of the rectangle you want. So there we go.
Are you gonna have a formula for the triangles or something, or are we gonna have?
No, you have to know those.
Jeez, you're killing me.
I mean. Okay, for the area, what was the area of this thing? So first we need to do a survey. There's obviously 2 pieces here. Some people said we're going to find the area of the whole thing, and then we're going to subtract away this little bite. Other people might say, I'm going to take the area of the main part and I'm going to add that little tab on the left side.
You can find the area of the whole thing or the way it is. You don't have to cut anything apart.
And
What's the easiest way?
then a very few people will say, I'm going to find the area by taking this top skinny rectangle and adding a bottom skinny rectangle. But it's rare that I hear people do that. So who did this big part minus little part way in their head? Anyone do that? Okay, let's do it for people who were. So it's 6 by 2.5. And then this one was 1.5 by 2. So what's 6 times 2.5?
How'd you get 1.5?
Because it was the 2 minus the 1.
Oh, okay. Because I was gonna say, if you look at the actual picture and you see where it says 2 inches, they're exactly the same
Nine.
height. So it would be 2, to me, it's 2 inches.
No, it's not quite to scale.
9. 6, 10, 25, right?
No, 2.5, because we're finding this big,
Alright.
so 6,
15.
15, yeah, 6 and 6 is 12, and half of 6 would be 3 more, so 15. So this is 15 square inches. And then 2 times 1.5? 3, right? 2, and then half of 2 is another 1. So 3 square inches. So then our area would be the 15 minus the 3 is 12 square inches. So that's one way to do it. If you were doing it this way, then we have, going back, a 4 and a 2.5. So, and then on this side, we had a 1 and a 2. So 2 times 1 is 2. 4 times 2.5, well, 4 and another 4 is 8. And then half of 4 is 2 more, so 10. So then the area is going to be the little rectangle plus the big rectangle. So same 12 we got last time, but different method. So these are a little bit interesting. You get to sort of make a plan. Which pieces are you gluing together? Which bites are you taking out? Whatever plan you make, each shape in your plan will be its own term, whether you're adding them or subtracting them. Let's look at something a little more complicated. So find the area of that kind of house shape. We know that the area of a triangle was 1/2 times base times height. And we know that the area of a rectangle is length times width.
So what are we trying to find?
The whole pink area.
Why didn't it be all 3 of those numbers multiplied together?
It's not just the 3 numbers multiplied.
Sometimes. So pretty.
This one is a.
Yes. But it shouldn't be too hard to memorize because remember the
Coming back this way.
remember this thing? Triangles are half of their rectangles.
Uh,
Triangles are half of their rectangles. So this is where we got the the area is 1/2 times base times height. They filled up half of their rectangles. Rectangles are base times height.
Oh, okay. So it would be the same in
My suggestion is when you're doing these kind of puzzle problems, to start by writing an equation that has no formulas. Just say, I'm going to do that, and then I'm going to do that. Make sure you have a good plan. Everyone with me? If you start trying to put in length and width and base and height stuff yet, you're going to confuse yourself on the day of the test because our brains all shut down on test days. So first line, no symbols, no word, no letters, just make your plan. What you're adding, what you're subtracting. Then on your next line, put in the formulas. And you'll see that each shape in your plan is its own term. And then on your third line, finally plug things in. What's the base of my triangle? 10. What's my height of my triangle?
height of your triangle is.
So this much was 18. 12 of it was the rectangle. 6. Everyone okay with that? And then length and width, I have 10 and 12.
Plus 10 times 12.
Yep, 10 going across and 12 going up. So let's look at all these steps again. On the top line, I'm just making a plan. Don't write any letters, formulas, or things like that. On the second line, for each shape in your plan, put the formula. What we did a couple weeks ago at the end of the science chapter with all that paper folding and formulas. On your third line, wherever you have letters, plug in the right things. Sometimes this is a little tricky. Like what was the height of the triangle? I had to go 18 minus 12 to see that there's 6 left to get from here to here. Once I've plugged things in, my work is done. The calculator does all the rest and you get an answer. Remember to label the answer because it's a word problem. Ready to do another one?
Sure.
Okay. Oops, wrong one. Okay, before we do another one, a little warning. What's the area of this square?
4 times 4.
4 times 4, so 16, right? If I label the other sides, the area is still 16. I'm just labeling more. So it doesn't magically turn into a perimeter problem where I add everything up just because I'm labeling more. In this case, it would be 16, but it would be linear instead of area. I should make it in 5s. Anyway, so don't get confused by what's labeled. Sometimes they haven't labeled quite enough, like the height of the roof of the house. And other times they label extra stuff you don't care about. So don't worry about that. Make your plan. Okay, here's a problem like a staircase. So it's 6 centimeters this way, 6 centimeters that way, and because we have 6 steps, each one is 1 centimeter going up or across. So what's the total area of the staircase? Yeah. Yeah, there will be one problem on the final. That's one of these puzzly.
Just like that, with the little stairs and stuff.
It won't be this one. There's a bunch of them. If you go to the final, then you can see that when you reload it, the shape changes.
Yeah.
So if you took enough practice finals, you might finally get all of them having seen before. But there's an awful lot of them. Okay, back to the one that we are doing. So what's my first step?
Figuring out what to say.
This step.
The steps, yeah.
Yeah, just a plan, right? So total. What is my plan?
And what is the big triangles?
Big triangle, that's a great thing to say first. So I have my big triangle,
And then the little.
and then here's a little triangle. How many of them are there? Yeah, 6 times little triangle. Everyone like my plan?
Yeah.
Okay, it's next line. Put in the formulas. 1/2 times base times height plus 6 times 1/2
So
times
base
base
is
times height.
6. Oh, wait, base is 6 and the height. 6.
Okay, 1/2. Yes, this one, base and height are both 6.
Plus.
And that one, the base and height were both 1. Because it tells you that.
Wait a minute. Plus 6. I didn't do that. Why is that so good?
What part's confusing?
Get the half the base times the height plus y is plus 6. I thought it was half the base, and then length and width.
There's no length and width because I have no rectangles.
Okay.
It's the big triangle plus 6 of the little triangles.
Oh, so it's. I don't get the second half of it, I get the half of 6 times 6.
A big shape plus 6 little shapes. Each shape I have to change into a formula.
So you're adding 6 because there's 6 of those little.
There's a 6 times because I have 6 of them. And I could do +1 +1 +1 6 times, right? But that would just be too long. Question?
Yeah, how do you get the measurements for the small triangles?
Because it tells me right here.
If
If it didn't tell me that, I could just say, oh, there's 6 steps. Together they go 6 centimeters. They're all the same. So it has to be 1 each. But they were nice and just rolled. Okay, now it's calculator time. So 0.5 times 6 times 6 plus 6 times 0.5. So I get 21.
Plus 6 times 0.5.
If numbers had flavors, there's different flavors of number here. This 6 is one flavor, the black 6. This is because there's 6 of those shapes on the picture. If we drew a different picture, maybe this stem had rotted away over the years, and there's only 5,
And then every.
then it would be fine, right? A different flavor of number are these halves, or 0.5s if you're putting decimals in numbers.
Why is
So the
it?
half is there because it's from the formula. Nothing is measured a half. It's not like we have a half of a shape. It's just that the formula makes us use halves. And then the last flavor of number are the bases and heights. That's what's actually measured in the shape.
Because it's one on that side and one on that side.
Right? So we have 3 different kinds of numbers. We have the ones that are just counting things in our plan. We
Okay.
have the ones that come from the formulas.
So just
Yeah, we have
basically
the-
of the little ones, okay, I confused myself, I get it now, because it's one on that side and one on that. Sorry, I just didn't understand.
It's 1 and 1.
That makes sense.
This
See, when I had those numbers there. Ones that comes under that same color, I forget. I'm just saying.
Okay, questions about this one now that it's all been on the board?
Yeah. 35 of them.
65 at the lowest.
Should I ask her?
We can do that. Okay, take a break from that. Let's see. Oh, come on. Yeah. So the final exam has 35 problems. So if you're trying to scrape by with passing, what is 65% of 35? We did this yesterday. How do you solve this percent sentence? So if you're a translate one, and y equals 0.65 times 35. So it's about 23, right? So don't stop at number 23, but you can get partial credit on a few, and a 65 isn't actually that bad. So you could miss about 12, and I'll get some partial credit. But you don't have to worry about this because you can do practice tests and see, are you getting 23 right? No.
Yeah.
So then do more practice tests.
Oh, I have time.
So similarly on the no calculator test, then if you need 65 on this, there's 19 of them. So what is 65% of 19? So that's about round up.
Ew, I don't like that.
So try and get 13 out of the 19.
I actually turned it into
We get A for effort.
No.
Yeah, come on, we know we try to really.
you saw me saying.
Yeah. Like,
Yeah, it was a little like.
I'm gonna take my new one.
So, but this shouldn't be a big uncertainty on the day you actually take these, right? For Wednesday with this one, do some practice ones. So when you show up on Wednesday, you're pretty sure you're at 13 or more.
I don't know about that. I think you should do easier numbers.
Okay. Where were we? We were over here. Here's a tricky one. What's the area of the sidewalk And we have measurements for the outside edges of the sidewalk and the outside edges of the building. This isometric picture makes it look complicated. So it's nice if we redraw the picture. So there we go. The building is the green rectangle. The sidewalk is the purple shaded area. So what's my plan going to be? How am I going to get to that purple L-shaped thing? There's no triangles. And I don't want any formula stuff yet. I'm just wanting the plan. I don't want numbers. I just want a plan. I want like big thing, big this thing, or little this thing. Or something.
Like,
Square,
Big rectangle.
little one.
What about the little one?
I feel like somebody knows which one goes.
It's definitely not.
A little right.
Once I found the big rectangle, then how do I get to only, yeah, subtract my little green one? Now everyone's happy. We're taking a bite out of it. We're removing this part.
Need it.
Okay, now I can use formula. So this is a length times width because it's a rectangle. And this is a length times width because it's a rectangle.
So the big one.
So what is this? 113.4 times 75.4 minus 110 times 72.
Wow.
I probably should round it down to 630 because we're actually doing construction with concrete and we're not going to be accurate to the 10th of a square foot. Okay, does that one make sense? Everyone sees why we're subtracting?
No, I see it.
We're subtracting because we have a rectangle and then we're going to take this smaller bit and get rid of it. So we're taking it away.
I am too. This would be nice though.
The steps are all the same. The first one, we make our plan. The second one, we change the shapes on our plan into the formulas. The third one, we plug in the numbers, and then the calculator does all the. Anyone need more time with this? Yes, people are ready. So it's generally true, I've told you, that after class you should go back to the lecture notes and try and do the problems without looking at the answers. Right? Today it's especially important for that. Go back as soon as you have some time. I know you have jobs and kids, but try and do these problems without peeking at our notes. See if you can do them when you get home. No, in 25 you can, but not in 20. 25, everything is open book. No, 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 go back.
Nice to meet you. Nice.
Doesn't
Yeah.
Well, very first day that Math 20 is about turning free time into grade checks. So there's nothing shameful if you have lots of jobs and kids and no free time of taking 2 terms. It's a little more expensive with time, with money, but if someone else has done more homework than you and you're going to spread out your homework over 2 terms, then that might be what it is. But no, study lots. Spend all your time now. Get it done. It's cheaper. Okay, so Catriona Shear makes puzzles like this. If you like this kind of thing, you can go to her Twitter account. And Naoki Inaba makes puzzles like this. If you like that kind of thing, you can go to his account. But there we go. Okay, our last topic is just a tiny, teensy little bit about variables and negatives. Just so you'll have seen this, because your Math 60 teachers want me to show you this. So negative numbers are less than 0. Is there anyone that's never seen a number line before in other math classes? Should we talk about number lines? No, you all know number lines? Okay, so here we have 0. Negative numbers go up this way. You can have decimals, right? Whereas 3.5 is a positive, it would be halfway going up from 3 to 4. Whereas negative 2.8 would be heading down past 2 and almost get 3. So if I asked you to put things on number lines, you could, but I won't ask you. To add and subtract with positive and negative together, it's helpful to think of money, because all of us have earned money and gone in debt. A positive number would be money you have in your hand to spend. A negative number is like a debt you promised to pay. And it's good to make up stories. So here is some stories. What is 30 plus negative 12? You can think, well, I have $30 in my hand and going shopping. I owe my friend $12. So it's really like I only have 18 to spend, because 12 is allocated already for my friend. If I spend to that, he's going to get upset. Or if you say, what's 18 minus negative 12? That would be saying, I'm about to go spend 18. I also owe my friend 12, and I have that money in my other pocket. But my friend comes to me and says, never mind that debt, it's been 7 years anyway, you just keep the money. So by removing the debt, by subtracting the negative, now I have that $12 in my second pocket to spend. I've gained 12. So the 18 gaining 12 is good. So something like that. It's nice to think about stories, usually involving money, if negatives are part of the thing. You can also use a number line. This is inconvenient because you have to have something to draw on, but it does work. So if I have 4 and I take away 6, 1, 2, 3, 4, 5, 6, I'm down at negative 2. And then if I take away 3 more, I have a debt of 3. And then my other friend comes by and cancels a debt of 10. And then somebody else comes by and steals 2 of my dollars. Then I wind up at 3. Oops. Right. I don't think you actually have any of these on the test. We'll check in a moment. And then for the negative of a negative is a positive. Remember back when we did the walking forwards and backwards, right? If you did 2 kinds of negative at once, it made you go in the positive direction. So we've talked about that already. Perhaps the most important thing in all of this section is that if you think about it carefully, if I have 10 minus x in part of a formula somewhere, if I plug in 20, 10 minus 20, I'm now negative 10, right? But if I plug in negative 20, I have $10 and someone cancels out the $20 debt. Now I'm up to 30. So I could have a negative thing. I could have a positive. This expression itself, the 10 minus x, isn't negative or positive. It depends on what you plug in. And in fact, even if I just have a plain x, it's not negative or positive. If I put in positive 5, it's a positive number. If I put in negative 5, it's a negative number. So if you're going on to 60 after this class, the weird thing to get into your brain is that the letters in your stuff don't have an inherent positive or negative value. It depends on what you're plugging in. Question?
I don't know if these are more considered like a trick question or not, but I've seen problems that were like -10 and then minus like x, which has always been weird to me.
To have something say -10 and then take away x more?
Yeah.
Yeah, so again, stories are good. So I have an empty wallet. In one pocket, I have $10 that I need to give to one of my friends. That's my debt of 10. And now someone else comes to me and reminds me, hey, remember you owed me some amount of money? And they're not quite sure how much. So, or maybe it's the other way. Maybe I have the $10 for one friend in my pocket, and I'm about to walk to his or her house and pay off my debt. And someone else, could be a negative thing. Maybe I also owed someone else $10. And they said, no, never mind, you keep the money. I like your pancakes, or something like that. And so now I have more money than I did because something I had allocated to pay off the debt is now free, I can spend. So again, x could be negative, x could be positive. And if I just tell you that now for 5 minutes, then it will help you in Math 60. Except if you're not going to Math 60, and oh well. So that's the end. You didn't have that many questions at the beginning of class, so we got all the way through this. The rest of the term is review. I warned you early on in the term, there's 2 kinds of Math 20 classes. Very rarely, like never, people will ask me enough questions during the term that we finish up at the end of week 10 and take the final during finals week. What always happens instead is like this. We finish early because you didn't ask me enough questions as we went through everything. So now we have more than a week to review everything because we're done with new stuff. So the advantage of this is that Panic will help you get your questions now that you didn't have earlier in the term. So yes, there's the famous saying, with patience, you can have all things. With impatience, you can have all things faster. So, okay, any last question? We have 5 minutes. I can do something on the board. Can you, don't skip class to do practice tests. That's not a good idea, but. Yes, one thing that will happen now. This is a good point. Thank you for your segue. Up until this class, even the beginning of this class, when I say, what problems do you have for me? Everything you've been suggesting has been on the turn-in homework, because that's what you've been paying most attention to. So what's going to start happening, probably as soon as Friday, is when I start class and they say, what's a question someone has from your studying? It won't be the turn-in homework. More often than not, it's going to be a practice test of the no calculator test or the practice final, right? So yeah, bring those to me, because if we don't have things to work on, I'm just going to guess what you need review on. And I've done this before. I have a pretty good guess on what you need review on, but it's better if you tell me what you really need review on, and I'm not guessing. So do homework, bring questions.
So do you know, like, if I was the